Hello, my name is William Jackson Cline. I'm in section K-12 for Physics 2212, and this is Lab 1 charge tapes. Some introductory information. The main ideas of this lab are electric charges, electric fields, electric forces, and interactions between charged objects. The purpose of this lab is to determine the amount of excess charge on one piece of tape. Some principles of this are Coulomb's law, which is shown on the slide here. This is for the electric force. To find the equation for the electric field, simply divide this by Q, which is the charge of one of the objects. Newton's third law, which states that a force between two objects is accompanied with an equal and opposite force between the second object onto the first. Some of the results from this lab, I found that the tape was negatively charged based on its interactions with other objects. I found that the tape has a charge of 4.49 times 10 to the negative 9th coulombs when it's treated as a point charge. I used the Coulomb's law equation since I knew the electric force and force of gravity were equal, and I knew the distance between the two objects when the force took place. I could rearrange, solve for Q, and find the charge then. And I found that the tape has 2.81 times 10 to the 10th excess electrons. I found this by dividing the charge of the tape by the charge of an electron, which is 1.6 times 10 to the negative 19th coulombs, to get my excess electrons on the tape. In these calculations, I treated the tape as a point charge, but later I showed as a line charge in the Glowscript code. Some assumptions: I assumed that charge was evenly distributed along the tape and that each U-tape was charged the same. I ignored air resistance and outside charges. And the system was only the U-tape and whatever object was interacting with it. Some potential errors are error in measurement, faulty charge on the pen, and different charges from interactions with other objects. Here's my data that I found for the experiment. Since I knew that the electric force and gravitational force were equal, I was able to calculate the charge on the tape. I measured the distance between the two tapes, which is approximately 0.01 meters. I used that in other calculations as well. The ratio between excess electrons to atoms in the tape was 7.246 times 10 to the negative 8th electrons per one atom. And I found that tape was negatively charged. This is because it experienced a repulsion from the negatively charged pen. However, this could be a source of error, as the pen might not have been charged as it should have been. When the tape was modeled as a line of charges, the magnitude of the charge was 7.74 times 10 to the negative 4th. This is very different from what I calculated for the point charge. However, the line charge is supposed to be greater. This is because in a line charge, the top tape experiences forces from all the different atoms in the bottom tape, or all the different electrons, and this is more representative since the electrons give off a field and don't direct their force at simply one other atom. I assumed the charge was evenly distributed and that each point contributed the same magnitude of charge. One of the questions asks if electrons and protons switch signs, if there would be a difference, and no, there would not. The interactions would be the same, and since electrons and protons each exert the same force but opposite, the interactions and magnitudes would stay the same as well. The force from a line charge is greater because of what I explained earlier, how each electron exerts forces on different atoms, which means that the net charge would be larger, and the line charge is more accurate because there's not just one electron on the tape. There are many electrons spread out, so line charge is much more accurate in this context. Here's my Glowscript model. The red spheres are the atoms at the top tape, blue are the atoms at the bottom tape, the white arrow is the net electric force vector, the yellow arrow is the gravitational force vector, and the green arrows represent the electric field vectors acting on the top tape. You can see on the bottom, it also shows the electric force and the gravitational force. Gravitational force is simply mass times gravity, and the electric force is based on Coulomb's law and the distances that we found earlier. Differences in charges that we found earlier. In conclusion, I determined that the tape was negatively charged, which explained how it interacted with other objects. Since this tape repelled anything that was negative and it was attracted to anything that was positive or neutral, I found that it had a negative charge. Since it experiences a repulsion force with another U-tape, I was able to prove that these exerted an electric force on each other. And then Putting it in equilibrium with the gravitational force allowed me to solve for the charge on the tape, which allowed me to make that Glowscript model and determine the charges in different contexts, as well as the number of excess electrons and ratio for the tape. This lab was very good, and it taught me how electric forces act in context. It was a great real-life representation, and it really increased my understanding on how these forces act between objects in real life. Thank you so much for your time, and I hope you have a great day.